Okay, let's look at this question, how to solve this. Okay. So you need to observe that this we can see this as an inside function, yeah, inside function, where I would say let's make u equals to x squared plus 3. Okay, so that with this we know that du over dx is 2x. all right. Okay, so when you make the substitution, okay, when you make the substitution, make the subs. Let me do it here. When you make the subs, you will see that 2x x cubed plus 3 to the power 4 dx. Okay, you can replace the inside one here with u. all right, so this will become the u, and then you can see here du can becomes 2x dx. So that means we can replace this too with du, so the whole thing becomes u to the power of 4 du. Can you see that? Okay, the simplification. So now this becomes really easy to solve. U to the power of 4 will just become u to the power of 5 divided by 5 plus the constant c. And then what you need to do is just replace, substitute u back here, this one back in this equation, so it will become x squared plus 3 to the power of 5 divided by 5 plus c. Okay, so that's the answer. Let me give you another example quickly. I'm just going to cover as many examples as possible today so that you can practice. Okay, let's say example, let's do something involving surd or square root. Okay, I'm just going to put 3 here. Okay, so how are we going to solve this? Okay, I'm going to use the magenta. All right, now the inside function, I really like to work with this one here. So this one I will set it to be I'll set this to be u. So u would be 3x plus 1, so that du dx would be just 3, and then du would be 3 dx. I'm just moving this to this side here. all right, so again, make the substitution, make the subs. I'm rewriting the equation, the integration question problem. all right, so I'm replacing this here with u. Now I'm replacing this here with this here. So what I've got here is basically it's just u du. all right, so well, that will be equal to just u to the power of half, or 1 over 2, and then using the formula, this will become 2 divided by 2 over 3 down here, so it will be 3 down here and 2 here. Okay, oh, don't forget your constant. Okay, so what happened? Oh man. Okay, so that's an example. Another examples. Okay, let's try different harder ones. X cubed plus 1 to the power of say that. Okay, again, let's the inside function, I think maybe we can pick in the inside function to be this one here. So this would be u. So u will be x cubed plus 1. So du dx is well, 3x squared plus 1. Okay, and then which means that du is equal to 3x squared dx. Okay, again, so make the substitution. Okay, I'm gonna write it this way: x cubed plus 1, and then I put x squared here, dx. Okay, to make it clearer. Now we know that inside here we can replace it with u. Now outside here, you see this is not as straightforward as before. Now we get this 3 here. So what do we do here? Okay, so what we do is we just add 1/3 at the front. Okay, because we know that let's say for example, you can say 1/3 of du is basically x squared dx. So we can use this. We just put 1/3 in the front. Okay, and then rewrite the whole equation: u to the power 3/2, and then because this is equivalent to this, okay, so I can just write. Okay, I just put 1/3 outside here. So you can solve the equation now easily. Put 1/3 outside here and then solve whatever is the inside there. There will be this is our plus 2 plus 5 2, so that will be u to the power of 5/2. We put 5 down here. Oh wait, you know what? I made a mistake up here. Up here it should be 3/2. Yeah, nobody corrected me on that one. Alright, so here 2, and then plus constant, because this is a constant. Anything times constant will be another constant, so I'll just write it this way. 1/2. Oh wait, so I'm just leaving it outside. Plus c. So 2/8 would be no, 2/15. So it will become 2/15 u 5 to the power of 2. Okay, and then rewrite u again with x cubed. So 2/15 x cubed plus 1 over 5/2 plus c. Alright, so that's another example. Let me do another example here. It's simple ones. Let's say let's work with e because this is, well, favorite. Favorite in a way that it is kind of tricks you a bit. Okay, so in this case, I will make this thing here, this whole thing here, as u, so that I will have u equals to minus 3/x, 3 times x, du over dx will be just minus 3, so du will be minus 3 dx. So again, make the substitution, make the subs. Okay, I will just write it down like this. I will just write it down. So this will become e to the power of u, and then dx, du means minus 3 dx. So in this case, dx is minus 1/3 du. So I'll just replace that. So times minus 1/3 du. Alright, make the substitution again. Du. So now you got the answer is minus 1/3, because if you integrate e, any logarithmic function, you'll get the same thing. Sorry, exponential function. Just get that again, plus c e minus 3x plus c. Okay, so let's try something with a rational function. Okay, let's find x. What should I put down here? Maybe 3x cube. No, not cube. Let's try square. Don't want to complicate stuff too much. Okay, so now what's your choice of u? Can you tell me what do you want the choice of u would be? I will pick this one. Okay, and let's see what happened. Let's see what happened here. 6x plus 1, so du equivalent to 6x dx. Okay, so again, make the substitution. Okay, I will have x 3x plus 1 dx. Okay, so now I need to replace the x, so dx here, since du equals that, so dx will be equal to 1 no, so in this case, since du equals to 6x times dx, so x dx will be equivalent to 1 over 6 du. Alright, so I have x dx here, so you can see here. Alright, so I can replace that with 1/6 du, and then I can replace this with u. So what I'm getting is 1 over u, and then dx is 1 over 6 du. So du here, 1 over 6, I put it outside here because it's basically just a constant. So what do you get when you integrate a rational function like this, 1 over u? You will get natural log of u. Make sure you put modulus there, plus c. Okay, and then if you rewrite the whole equation again, what you will get is basically 3x squared plus 1 plus c. So anything inside here is going to be positive anyways, because x squared is always positive, plus 1, that's always positive, so you can leave the answer like this. Okay, all right, so that's, I think, enough examples for that one. I think you get the idea, but let's move on to something a bit more I would say complex. Let's move on to something a bit more complex. Let me see if I can find a good question here. Let me see. Can you do this on your own? For example, I just give you a trigonometric function. Yeah. Let's say integrate what? Yeah. Let's say sine x plus 9 dx. Can you do this?
Negative cos x plus 9 plus c.
Perfect. Thanks. Siapa cakap tu?
Iman.
Nice, Iman. Alright. So I think what you did was you replace this with u and then try to find du dx, and then you got 1. so that means du is equal to dx, so that's easy. Alright. So let's take a look. Let's play around with trigonometric function. I think we've played around with power functions, exponents. Let's try this. let's say sine x cosine x dx. Well, let me make it harder for you. Let's put that in there. Okay, so how do you solve this? Again, you need to pick which one you should choose for you to make your life easier. So let's try. I'm picking sine x as my u. Okay, hopefully I will get something good. All right, here. So du dx is cosine x. All right. So in this case, I got du is equivalent to cosine dx. That's nice, because then I can replace this with just du. So what I'm getting there, what I'm getting at, make the subs. Okay, so what I got here is sine squared x cosine x dx. Okay, it's equivalent to, I've already replaced sine x with u, so I got that u squared. I've got this whole thing here replaced with du. So what I'm getting at, careful not to confuse differentiation with integration. Here I will get u to the power 3 divided by 3. Rewrite everything again. It will be sine cube x over 3 plus c. Okay, so I think that's pretty straightforward. Let's pick something that is not really straightforward. I've got this example. I found this a really cool example. Cool as in it complicates the situation a bit, just like what we did last Monday. It's something like this: x squared square root of x minus 1 dx. Okay, so let's see how we can do this. All right. So what I will want to do is, I see this as a composition. I see this as a smaller function. So I want to make u as x minus 1 as my du. So as u, so du dx will be just 1. So du will mean it's dx. Okay. So now I would say we need to do a bit of work here, because we need to work with this here. This is a big troublemaker there. So since we set u to be x minus 1, so we can say x is equivalent to u plus 1. Correct. So how do we deal with that? So let's deal with that. So that means x squared, which means will be x plus 1 squared, which will mean that it's squared plus 2u plus 1. Okay, so now we know x squared is that, so we can make the substitution. Try to make the substitution, make the subs. Okay, now we know, let's rewrite the whole thing again, and let's see if we can try and solve it easily. Okay, so we can replace this troublemaker here with, again, u squared plus 2u plus 1. Oh my god, it looks gonna be really complicated. Here we can replace it with just square root of u, and dx here is just du here. This is what we got before. Okay, all right, now it looks simpler, I think. So now what we're getting is, we've got sorry, there's something in my ear. So what we've got here is basically that times that, that's sum that, that's sum that. Okay, so that will be 5/2. Yeah, apa tu? And then plus u du. Okay. All right, so it's much easier than we thought. Now it's all we need to do is just treat it as individual functions separated by pluses. Okay, you can use the sum rule. So that will be equal to u 7/2, 2 here. Sorry, no. 7 here, 2 here, plus u 5 over 2, and because we got this nasty 5 there, maybe 5 here, 2 times 2 is 4, plus this one is easy, it's just u 3 over 2, 3 up here, 2 up here, plus c. Alright, so that is something really cool. And I need to show you another cool example that I found. Just want to show this to you guys. How do you try to solve this? Okay, I think first instinct is to make the substitution u to cosine x, but then although you can replace this with this later on, okay, then you got a problem of replacing this dx here, because du dx will be sine x. Oh, so minus sine x. Why do I find this sine x here? So that's a problem. So this doesn't work. Okay. All right. Let's try maybe try u equals to cosine squared x. Then we'll get again the same problem where you have you need to 2 cosine x times sine x. That. Okay, so that doesn't work. So let's try, maybe this will be a trick. You can see this as this cosine squared x cosine x dx. Okay, this is equivalent. Basically cosine cube x is a cosine x times cosine x times cosine x. So I want to replace it like this, and I want to look at this here, cosine x dx. So maybe I need to make u as sine x. Maybe this will work. Okay, so if I make this u as a sine x, then du dx will be cosine x. So du will just be cosine x dx. I think I can replace this here with du easily, but then I need to take care of this cosine squared. How do I relate cosine squared x and sine x? How do I relate this? Okay, I think if you can find some trigonometry identity, okay, you know that cosine squared x plus sine squared x is equal to 1. So cosine squared x is equal to 1 minus sine squared x. Are you familiar with this trigonometric identity? I hope you do. Okay.
Yes, doctor.
Nice. So I can rewrite this up here as 1 minus sine squared x cosine x dx. I can write it that way. So in that case, if I rewrite that, cosine cube x dx is equivalent to 1 minus sine squared x cosine x dx. Now I can replace this with du. I can replace this with 1 minus u squared. So this will become 1 minus u squared du. Now that's easy to solve. What you'll get, u plus u cube, not plus, minus, okay, over 3 plus constant, and then you just replace u with sine x again. There you go. You will get sine x minus sine cube x divided by 3. 3 plus C. So it's amazing that from this you can get this. Okay.